Morning, everyone. How are we all doing? Good, good. Welcome to day 2 of I.O. I am so excited to kick off today's dialogues with an in-depth conversation about artificial intelligence, which, if y'all were at the keynote yesterday, we heard about 121 times, according to artificial intelligence. And so today we're going to go a little bit deeper with the people who are behind so many of these advances. And these are the folks, you probably know a lot of them already, who are in the trenches behind the scenes. So joining me are 3 leaders who have made significant contributions, not only to Google AI, but I would say they have a track record of tech innovation all around the world. And we're going to hear a little bit about that. So starting with you, Jeff, I want to introduce you. This is Jeff Dean. Jeff is Google DeepMind and Google Research Chief Scientist.
Thank you.
Good. What's also interesting is Jeff is employee number 30 at Google, which is incredible. You've been here how many years?
Almost 25.
Almost 25 years. Over the years, he's developed many transformative technologies at Google, and he is currently the co-lead of Gemini, so assuming never a dull moment back there.
No, never a dull moment.
We also have Koray Kavochulu. He is the Chief Technology Officer of Google DeepMind. He is one of the world's leading experts in deep learning, and you've been in this for how many years, Koray?
Well, I mean, I think from the very early days of deep learning, so like 15 years or 15 to 20 years, something like that.
Amazing. Yeah. Incredible. And then last, we have James Menyika as SVP. As SVP, James leads Google Research, Google Labs and Technology and Society. And James oversees Google's most ambitious innovations in AI, computing, and science. Specifically, and we're going to talk about this a little bit later, he looks at the potential for beneficial applications and impact on society. So welcome.
Oh, thank you.
Great. I'm really excited to be here with y'all because I started covering tech in 2010. And it was such an interesting time. This was the rise of social media and mobile. And we saw so many industries that were created by developers with an idea. And now we're in another wave of innovation, this one fueled by advances in artificial intelligence. So Jeff, I want to start with you. And before we talk about where we are, let's talk about how we got there.
Yeah.
Take us through some of the major milestones that shaped where Google is today with AI. I think I read it was 2016 when the phrase AI first started circulating the halls of Google. So take us through it.
Yeah, I mean, maybe we can even go farther back because I think creating artificial intelligence systems has been a dream of computer scientists for 60 or 70 years. And for a long time, there was kind of an attempt to create intelligent systems through defining logical rules and letting the system kind of work with those logical rules in order to do kind of advanced things. But I think what we've discovered is that the real world is actually pretty messy, and logical rules don't always kind of give you the ability to generalize to new situations. And so really the whole community focused on machine learning as a technique where you can now learn from observations about the world and learn to do new things, which is what you care about, from observing how you're able to do some things and then generalize to new things. And so we've been using machine learning in various forms at Google since maybe 2001 or so. It was used for the did you mean spelling correction system, used in a core of our advertising systems and so on for many years. And then about 2010 or 11 or so, we started to be interested in neural networks, which were not necessarily a new idea. Actually, there was a wave of excitement about neural networks, which is a particular form of machine learning approach in like the late 80s and early 90s. And those systems could actually solve kind of toy problems that couldn't be solved in other ways. But they couldn't, at that time, really scale up to real problems that people encountered every day. But what happened in the intervening sort of 20 years was we suddenly got more and more computational power, and that enabled us to train not just 10 neural networks, but 10 million neural networks. And all of a sudden, the techniques from the 80s and 90s scaled up, started to work, and enabled us to now make progress on how do you actually tackle computer vision problems, speech recognition problems, and language understanding problems. And that has kind of been the arc for the last decade or maybe 13 years, is how do we actually continue to scale these systems up, innovate on improved algorithms, improved learning techniques, identify what kinds of data are useful for these, and really build systems that can generalize to new tasks from ones they've never seen.
And when you talk a lot about the advances in tech, Cry, you spent your career researching innovation. Do you believe that with artificial intelligence, it will follow a similar pattern of rapid advancement, or has the game changed? Is this going to fundamentally change the way new technologies are developed?
Yeah, thank you very much. I think that's one of the most important things. Like the reason, like as Jeff said, there was artificial intelligence and research into it has a long history, because I think it is sort of what you can think about as a multiplier technology, that research into it not just stays there, right? Like we see, as you said, how developers actually use it to do all sorts of new things, but it also impacts all of different fields and sciences, right? Like we start doing biology differently, chemistry differently. We start thinking about software development differently, right? Like it impacts itself as well. I think that's one of the very important things that, like as AI is developed, it's going to really fundamentally change how we think about a lot of different areas that impact our life. It is sort of like it will become a standard building block that we will then actually be concerned about more higher level things, more harder problems. A lot of the things that we are concerned right now, like probably they will be solved by systems that we are building now. And that will enable us to do a lot more, right? Like that's the exciting thing. Either the challenges that we need to solve, the technological advances that we need to make, like maybe like diseases we need to solve, all those kinds of things are being impacted by the technology at the core that is developing. That's the multiplier effect that I think is really, really exciting.
And Jeff touched on this a little bit. Thoughts like why we know AI is nothing new. Right. We know you guys have been talking about this for a long time. Why are we, be specific, why are we able to do things now from a research standpoint that we just couldn't do 10 years ago?
Yeah, I think, I mean, like Jeff gave a really, really good history there. I think right now what is culminating here is like our hardware investments are actually quite critical. It's one of the really important things that Google has invested over the years, that it just doesn't happen at once, right? Our understanding of algorithms has really improved a lot. And the current technologies that we have, these generative AI methods, right? Like for the first time now we are actually creating content, right? Like I can't actually stop looking. I see Refik Anadol there, like he's been at the forefront of that. I've been a fan of his work. So like when we start creating this content, it sort of all of a sudden starts influencing all sorts of different ways that you actually approach problems, right? I think that is quite important with the generative AI. Now we can go into many different fields, and just like we can think about a problem and come up with a solution, I think with these methods now we are at the stage that we can actually do that, and it starts helping people's creative processes or thinking processes, right? Like I think that's the life-changing thing. Like, I mean, we saw the video with Donald Glover when he was doing his films.
That was very
right?
cool.
Like that creative process, that speeding that up is a huge multiplier, right? Like for people to think through.
Yeah, maybe I would add something else to your question, Laurie, which is you asked why is it that we're able to do these remarkable things. I think there are a few things going on. One is what people have referred to as the so-called scaling laws, which seem to suggest that with these transformer-based architectures, the bigger you make it, the longer you train it for, the more data you give it. That's roughly what these scaling laws seem to suggest, that if you keep doing more of that, they get more and more capable. Then you couple that with other things. If you then add different modalities, if you then add things like long context, like we've just done, and you also start to add the ability to connect with other systems, either to use other tools, other mechanisms that are out there, all of a sudden the capabilities kind of become pretty exciting. the range of things you can now do, they just become much, much broader.
Yeah. Even from a storytelling perspective, watching a filmmaker, watching Donald Glover talk about this idea that anyone can be a director, and this idea that I'm a storyteller, we can make mistakes quicker using some of these things. It's all about making mistakes and understanding quicker, which is super interesting. You mentioned like multimodal, right? I'd love to hear, this is definitely the word we are hearing obviously a lot here. Well aware. We've heard quite a bit about Gemini yesterday and its multimodal approach to generative AI. Could you just pull back the curtain a little bit? This is an audience full of developers. How exactly do you envision Gemini in the landscape?
Yeah, I mean, I think some of these models in, say, 5 or 6 years ago were really focused on kind of human textual data, things like language, code. But one of the things we wanted to do when we started the Gemini effort was really make them multimodal so that they can deal with not just textual stuff, but also kind of traditional human modalities like audio, video, images, and both on the input side and on the output side, so that you can take in any of those modalities intermixed in various ways and produce any of those modalities on the output side. And I also think multimodal extends beyond what we think of as kind of the traditional human senses, because if you look at other domains, say the domain of healthcare, there's all kinds of other modalities that are not sort of strictly human ones. They are, genomic sequences, there's time series of interesting sensor data. Those are other modalities that these models can sometimes make use of when they're trained to make use of them in order to sort of accomplish things that we want them to do. And so really multimodality is about how can you take in all the relevant stuff in order to, understand it, understand the nuances of it, and accomplish some task the model's being asked to accomplish using all the available data.
Great. And James, I saw something you wrote in an op-ed where we always talk, there's obviously a lot of fear associated with advances in artificial intelligence and a lot of excitement. Both can exist. You said in this op-ed, people understand that artificial intelligence will disrupt their lives, but they hope it's for the better. We must not let them down. And I get the sense, first of all, that that's personal to you. I'm curious, could you be really specific? And could you take us through what you believe are just the biggest opportunities and applications for AI that would do what you're saying, that wouldn't let people down?
I think we tend to think of opportunities at least in 3 or 4 different ways, 3 or 4 different areas. One is a lot of what you saw yesterday, how you can advance what people are trying to do, whether they're trying to be creative, just productive, their everyday tasks, creative endeavors. So the kinds of things that individuals want to do for themselves, you can imagine those kinds of opportunities. I think there's a second important opportunity, which is, think of it as almost the economic opportunity. So think about entrepreneurs, small, medium-sized businesses, sectors that can be much better at what they do, healthcare or industrial systems, all the way up to what economists think of kind of as productivity growth, which is what drives economic growth and drives prosperity for everybody. So there's an important kind of economic dimension to the opportunities. I think there's a third and fourth other areas. The third one is actually just advancing science. I think one of the things that's been spectacular is just to see, the use of AI accelerate developments in so many scientific fields, whether it's the life sciences and biology, in climate science, in material science, in physics. So the possibilities in science, just to pick a couple of specific examples, in the last 3 weeks alone, we've been able to do at least 3 big things. You probably saw 3 weeks ago, we published a paper on our work on MedGemini, which is a Gemini fine-tuned for medical applications and medical data sets that is state-of-the-art, doing remarkable things. The second thing we also did at the same time was AlphaFold 3, which Corey and team worked on, which went from just being able to do protein structures to all of life's biomolecules, basically, DNA, RNA, ligands, and so forth. And then also recently, we developed a map, probably the first synaptic level map of the human brain, collaborated with others at Harvard. This is just the last 3 weeks
Wow.
of science, right? And then you also have all the societal applications that are already real today. I'll tell you some of my favorite ones. There's a small project, actually, that teams that Jeff and I work with started probably about a year and a half ago to try to figure out how to predict floods. So it turns out that if you're able to give people up to 7 days advance notice of floods, you can actually save a lot of lives and damage. People have known this for like 40 years. The question is, how do you actually do it? So a small project that began in Bangladesh and India that our teams worked on, it worked. So now we've scaled that up to now over 80 countries where we're able to give flood alerts. And these are 80 countries in places where something like 480 million people live. That's remarkable. You can wildfire alerts. So there's a lot of things in society that are starting to get better. But I think the key thing is, even as we get excited about all of that, we need to make sure we actually get it right. There's still, risks and other things we have to think about. But I think it's important to keep our eye, because the stuff that I just described, that's what I think motivates all of us. Think about how do we make and improve the world.
Yeah. Wow. I mean, the idea of like mapping the human brain, just the implications I can only imagine are pretty extraordinary. Jeff, I'd love to talk a little bit about efficiency. I mean, building at a certain speed, navigating so many of the complex societal challenges will obviously require much more capable systems and much more efficient systems. So how are you guys thinking about this?
Yeah, I mean, I think a lot of the advances are really about how do you build more efficient AI learning systems and then systems for deploying these models. And some of that is hardware innovation. So how can you build more efficient hardware that is tuned to the particular kinds of computations that you want to run when training models or when deploying them? Some of it is kind of software innovation in new algorithmic techniques or new training methodologies that can make it so that you can get to a certain level of accuracy with half the compute or a third of the compute. But really, it's about how do all these different things inform each other. And one of the things we have at Google is we actually have our own TPU hardware development team that is looking at what kinds of things we want to run, not just today, but since you're designing hardware, it kind of pops out of the design process a couple of years from now and then needs to be relevant for 3 or 4 years after that.
Yeah.
So you're trying to predict where is this extremely fast-moving field moving and where is it going to go and what algorithms do we want to use that maybe don't exist even yet 3 years from now. And that's a pretty challenging thing, but I think one of the things that really helps us is we have a lot of people working on sort of machine learning algorithmic research, people working on hardware, and those can inform each other in sort of this nice co-design process. But really, the more efficient we're able to make these systems, the more we'll be able to bring the benefits of AI to more and more people. So what runs in a giant data center today might, in a couple of years, run on your phone in a pretty reasonable way. And that will enable more and more interesting use cases, with, effectively an awesome AI model in your hand instead of a network connection away.
Well,
I think there's an aspect of also when it goes out, how it goes out. And I think one of the really incredible things at Google is we have such a broad range of products because interacting with the users is important, right? Understanding what kind of problems needs to be solved, what people really need help with, understanding those, and then deploying that technology also efficiently, but also in the right way, in the responsible way to the users and learning from that. I feel like it is quite important for us because our goal, we still have the scientific goal of building AGI, right? That's what we are still trying to do. And while doing that, actually, this whole setup is so important that we have to be interacting with the users. We have to be interacting and learning from that so that we solve the right problems the right way.
That's we were talking a little bit before this, and you were really emphasizing this idea of not building in a vacuum and being able to utilize this as a way to get a more understanding of how people are actually using this type of
exactly. And I think the huge opportunity that there exists right now is, of course, the whole world is now getting a lot more acquainted with AI. As you said, it is impacting all sorts of ways our lives. But also at the same time, I think we have the opportunity here at Google to build it and inject AI, to put AI into all sorts of products. I think it was really exciting, at least for me, to see how it happened across Google and how in many different ways people have thought about it.
Yeah, I think that one of the things that's been fascinating is when you see, I mean, Corey, you mentioned Rafiq, who's sitting over there as an artist. I mean, one of the things that's been fascinating is to see creatives and artists and real people working with these technologies and what they do with them. It's actually quite fascinating. I mean, so when you see artists, when you see developers and what they do, you learn a lot from it. In fact, there's been so many examples where our teams felt that they were building it to work like this. Then the artists and others said, no, we want it to work like this. Look what we can create. I've also been quite fascinated, Laurie, by a lot of the research that's now coming out. I think some of it has been done at Stanford and at MIT of what happens when workers start to use these technologies in assistive ways. And what a lot of that research, there's some great papers that have come out, David Otter and Eric Brynjolfsson and others have done this, show that, for example, it's often the least skilled workers who get the most out of it because, we haven't had don't have the expertise or the experience to be able to do it. They get the biggest uplift. So the possibilities of actually assisting work and assisting workers, I think it's phenomenal. So that's also quite interesting to see in the hands of real people, what do they do with this technology? And we learn a lot from that.
Right. And obviously with that, you put technology out, you put it out into the world, you see it used in incredible ways, and you see it misused in extraordinary ways as well. So to that end, James, I'm curious, you've said before, you've talked about this, AI presents complexities and risks that must be taken seriously, your words. Take us behind the scenes. Like, what is Google doing to mitigate those risks? How do you anticipate these challenges when you have technology that you almost sometimes don't know how it's going to be used?
Yeah, it's probably worth describing at least the way we think about the different complexities, and then I can say a little bit of what we're doing about it. I think there's one set of complexities and risks that have to do with when the technology doesn't actually perform and behave as any of us intend. Right, I don't think anybody builds a system that wants to build a system that hallucinates. Right, that's not helpful if you're trying to get factual information. I don't think anybody wants to build a system that's biased. So there's a whole bunch of things that we have to get right about how they perform. But even if they perform as any of us would like, there's always the possibility of misuse. Right, somebody actually using it to do things that none of us would like, whether that's somebody trying to, use it to create disinformation or do dangerous activities or whatever have you. That's another whole category of complexities to think through. And then finally, you've got the complexities about how this sort of works its way through society, the implications on work and other things. So we think about all of those things. But let me touch on what you asked about, which is to do with misinformation, for example. So you saw, we talked about this yesterday, about how we've been working pretty hard, and this is actually a lot of terrific work by Corey's teams, actually. Maybe you could talk about this too, but on SynthID, yes. Which is to try to watermark the generated outputs. I think the first time we did that for images and for audio, so now we've extended that to text and video. That's an attempt to try to make sure that at least there's a way to tell when something's been synthetically generated. That's one way. But there are other things we have to think about too. Can we provide provenance information about where was this done, where did it come from, etc. So there's still a lot of work to get that part right. And I think then there's also the question of new questions that will arise as this technology gets better. So the questions keep changing. So now we're talking about agentive capabilities. We're going to have to think that through as well. Now that we can do that, are there new questions we're going to have to think about to get that right as well?
And also, I mean, one of the things I've always said, okay, AI to fight AI is going to be such an interesting place of innovation too for folks to build on. And you mentioned yesterday, I saw this idea of AI red teaming. Just curious, if you could explain a little bit more about that too.
Yeah, actually, I should let Corey describe it because they invented the technique.
We'll put Corey in
with all the
in the
gaming,
hot seat.
all the
Yes.
DeepMind and all these amazing breakthroughs in AlphaGo and
Yeah, I think this goes back. Thank you very much, James. Thank you. This goes back to the fundamental techniques that we have been working on over the years, starting going back to like AlphaGo, AlphaZero, where we have trained the systems, these agents to play these really these board games, but they are really intellectually sophisticated, right? There, one of the fundamental things is the system to search and plan by itself and playing against itself, so that learning from that experience. And the same kind of idea, of course, applies here. When we have AI that is developed, we want to make sure that we can actually have like two AIs talking to each other, or multiple of them talking to each other, and make sure that we can find the different failure scenarios, we can find the different scenarios that are actually things working well, or things that are going sort of out of distribution. And from that, we can learn, and we can come up with ways how to avoid actually those kind of scenarios, bake that into the systems again. And this is a continuous process that actually needs to go, and it's part of the development, actually, of the whole AI system.
Yeah. What's been fascinating about that, Laurie, is the fact that it actually just, not only speeds things up, but it also just expands the scope of red teaming things that we can actually try and understand. In some ways, in ways that complements what human red teaming teams do. So we think the combination of the AI-assisted red teaming and the somewhat standard traditional red teaming teams going at this, it's a great way to discover the weaknesses in our system and try to keep working to improve them.
Great. You looked like you wanted to say something.
Oh, no, I just think like the ability for building systems that can automatically explore the fringe of possibilities is really important, because anytime you have a human in the loop in the traditional red teaming, there's a limited set of things you can actually explore. And I think there's actually parallels of this for red teaming purposes with, say, a lot of the beneficial uses for science, right? Like all of a sudden you can explore 10 million molecules that might be interesting while you go to lunch, rather than a sort of more human pace thing where you might take 6 months to explore 1,000. And all of a sudden that brings open, brings many new possibilities for how you conduct science or how you conduct red teaming.
Yeah, exactly. It's the same thing working over again in all areas. And we are sort of using the same technology that we are really proud that everyone is using. We are using it ourselves as well to explore and robustify everything we do.
Actually, you can get very meta with this stuff. So some of the things we're
By the way, I love how much they're geeking out over red teaming. It's awesome. Like,
no, because
I just had to know the code word was red team. Go ahead.
No, because one of the things we're doing a lot of work on, by the way, is where you can get even this idea of smaller models teaching larger models and vice versa.
Right.
Right. So the idea, so I think we're very rapidly moving to a place where the idea that there's some single model that does everything, I think we're evolving a lot beyond that. So often you have models working, coaching each other, teaching each other, generating better outputs, a smaller model, a faster model, maybe even combining a large language model-based system with a neurosymbolic reasoning engine that can do reasoning in a very different way. That's some of what happened with alpha geometry, for example, where we did that. So all of this is a lot of the incredible innovations that our teams are working on.
And this ties into the earlier question about how do you build more efficient systems, because when you have these large models that can teach small models, the small models suddenly become much, much better. And that makes them more efficient and able to be used in more cases with less computation and energy.
And we've touched on this. You just mentioned it with science and how these same models can be used for science. You were just tweeting about you think the biggest opportunities in AI are for healthcare too. So, James, your time, you have an interesting background. You undergrad in Zimbabwe. You from your time now, Google current advisory roles for the White House and United Nations. Busy schedule, I'm assuming. I'm just curious, how have these different experiences shaped your perspective, especially when it comes to the promise and also the peril of new innovation?
Yeah, I think if I think about my own personal background, but also just looking at this through this work with the UN and other things, I think it's a great reminder as to why we're doing this work.
Why are you doing this work?
No, why we are doing this, why I'm doing this work, right? I think which is, you see all the possibilities, but you also see the gaps and mismatches. So, for example, with this work we're doing with, through the UN, looking at all the, the whole world, the global south and other places, you suddenly realize that not everybody is participating both in the development and use and the benefits of this technology. We have to solve for that. You also realize that, even if there are economic opportunities from all this, there's nothing automatic about everybody benefiting from that. We have to work on that. So it's a reminder that even the amazing things that we're talking about here aren't going to automatically get to everybody. So it's a reminder for me about the importance of thinking about how do we make sure we get to everybody? How do we make sure, even when we think about things like language translation, we're trying to translate all the languages, not just some. One of the things, for example, that our teams are working on. So if I think the numbers are something like, if you wanted to get to all the languages spoken by 96% of humanity, you'd have to translate just over 7,000 languages, right? And so one of the goals that our teams have is to at least get beyond 1,000, and so to get to everybody. You suddenly also realize that there's so many other barriers, whether it's language or access to things that people have. We have to solve for that. So I'm actually very proud of the fact that our teams are trying to work on, in some cases, preserving languages. I remember Rafik actually introduced me to a group in Brazil where there's, I think, only like 36 people left who speak this language.
Wow.
Right, left. So we're trying to think about, is there a way to use AI to preserve that language in some fundamental way? So it makes you think about those kinds of things.
Cool. Yeah. I love a good lightning round, always fun. And so I figure we have some time, so we can do like a lightning plus round. You don't have to be so concise, right? But I'm curious, just quick questions, semi-quick-ish answers. And we'll start with one that I would love for all of y'all to respond to. We'll start with you, Koray. What is the one thing you are most excited to see come into fruition in the near future, and what's needed to get there?
I think, all right. One of the things that I'm really excited about is from top of mind, of course, using AI in our own field, in our own in the developer ecosystem, really fully. Right, we are getting there, we are using it more and more, and it is becoming part of our daily lives. Even when we are building AI, we are figuring out ways that we can actually use our own models to help with our own processes. And I think it just needs to, the quality needs to be higher, the understanding of the models needs to be higher. I'm quite excited that a year from now, actually, we are going to look at a different way of working in software development, in software engineering. The capabilities are really exciting right now, and they are improving. That's top of mind.
When you say a different way of working, in what sense? Could you paint that picture?
Well, I mean, I think right now, we have all sorts of tools and capabilities to help with our code, to help with our our development environment. Right? But as these environments become more integrated, now, if you remember the Astra demo, one thing that happened there was from the video of the code, the system actually could tell what the person was working on and what they are developing. Right? There was an example of a developer saying that a whole new library that they didn't know how to use well, it could actually go and teach them about it, and it could actually suggest changes. Right? Mm-hmm. So this actually enables the developers to think at a much higher level, right? You're not getting stuck in the tiny details of what you're trying to achieve. Sometimes that can become frustrating, right? So that, again, we are coming back to this same idea that it speeds up the process of experimentation for developers. And I think, as we speed up the process of experimentation for developers, then the productivity increases a lot, the experimentation increases a lot, then we end up with much more powerful applications and more powerful products.
Great. Jeff, how about you? One thing you're most excited to see in the future, and what has to happen for it to come into fruition?
Yeah, I mean, I think maybe building on Koray's answer, which was more about software development, I think the more general thing that we want to see is right now these models are kind of capable of taking somewhat complex requests, maybe breaking them down into 4 or 5 things that the model kind of knows it needs to put together in order to sort of accomplish that request. But it generally can't do something that requires 60 steps. Right. And so how can we build something where you can give a very high level, request to one of these models in, software development or, something you want to do in your daily life or in science, and it can actually know how to break that down into a bunch of different steps, maybe use some external tools in order to help it accomplish some of those steps, explore the space of the way in which it might want to do this, have some interactive dialogue with the person, like if there's, ambiguity, should I try this or should I do this, or you prefer this? Right. Yeah. And I think really building much more capable models that kind of can, embody solving really complicated problems rather than sort of medium level complexity ones that they're sort of sometimes able to do now. That's going to require a lot of innovation in machine learning techniques and algorithms, and how do you sort of train the models in domains that are maybe less clear, where you can, in things like math or Go or chess, you can use self-play and it's very clear what the outcome was. In, help me organize my scientific thoughts and plan some next experiments I should do. That's not necessarily as clearly, right or wrong.
I always like asking the people who are building the products how they're actually using it behind the scenes. So James, this one is for you. What is the strangest, and just be honest, strangest or most noteworthy way you've used your own products or AI in your personal or professional life?
Well, there's actually something I'm using a lot right now. So a few months ago, once we had this idea of long context, I challenged one of our teams to say, look, there's a problem that I have, which is there's so much incredible research coming out, all these hundreds of papers all the time. So I said, can you build something that allows me to browse all these papers very, very quickly? So we actually built something called Illuminate. In fact, it's going to be out in labs, I think, maybe in the next few days. So basically what it does is you can put in kind of papers that are published on archive or wherever it is into it. And then basically it generates a set of conversations about all those papers. Because it has long context, you can put in, 20 papers or something. So you can say, hey, find me all of Jeff Dean's latest papers, put them in, and generates a conversation about those papers in short order. Then you can go and dig up and look at the original source. I love that. I use that a lot. So I think it's going to be out in Google Labs in the next few days. You should try it. It's fun.
I will. I'm 100%. I wanted to look through a DeepMind paper all around ethics, and I was like, I wish it was like 250 pages. And I was like,
that was a long paper.
That was a lot. I mean, I'm glad, but I was like, I need a program to help me sort through this.
You can get a podcast about it now.
What'd you say?
Exactly.
You can get a podcast about it.
Right. That's
automatically generated.
That's wild. Okay, Jeff, when I was doing research for this, I asked them, I was like, I want to find some information on them. They were like, well, look no further than his Google Scholar page, because there's like, I don't know how many research papers you have from having.
See why I had to have this product?
I understand. Honestly, I understand in doing research for this panel. You had, I don't even know how many of your papers that you've co-authored are on this site. It's like, not dozens. It has to be like, I don't even know. I'm not going to say the incorrect one. But so you have dozens of research papers, many, maybe even hundreds that you've co-authored. Pick one. Which is your favorite? I know that's a hard one.
Just one. It's like picking.
But you have 2 minutes, so like,
I have multiple children. Yeah. I think if you go back even pre-AI, I think one of the papers that I really enjoyed working on was a system called MapReduce. With my colleague Sanjay Gamawat, who has been, my colleague for almost 30 years now. I think that's really credit to Sanjay's clear thinking of like, how can you build a really nice, clean abstraction about what you as a developer want to express, but then have a nice implementation of it that enables sort of fairly large-scale processing of data or transforming of data to then happen under the covers in a way that deals with, okay, I have this very simple thing I'm trying to express, but I would actually need to run it over a lot of data. And how do I make it run on 1,000 machines? And the system can then automatically deal with deciding which machine does what. And if one of the machines fails, it deals with figuring out what work that one did and then spreading it out over the other 200 machines to recover quickly. I think good abstractions are like a really nice thing as a computer scientist, because then they enable you to build on top of them other things that sort of have a nice layering property where you can improve things underneath and everything gets better on top.
Cool. James, you spent your career, I would say, just like researching the cutting edge technology, researching cutting edge technology, spending so much time in tech. What have you learned about humans, about people?
That we're complicated.
It's fair.
No, I think one of the realizations I'm sure lots of us have had is that you suddenly realize that a lot of these questions about technology are really questions about us as humans. And many of these are actually questions that we've been grappling with for thousands of years in many respects. And now finally AI is kind of holding a mirror to our face. So if you think about all these things that we think about, like we want AI systems that are not biased, that are fair, that reflect human values, all of a sudden we actually have to grapple with those questions ourselves as society, as humans, not as technologists, but as humans. So what does that actually mean? To reflect human values, which ones? We haven't agreed on many of those things for a long time, except for maybe at some fundamentally basic level of, I don't know, respect human rights and those kinds. But beyond that, these are very complicated, very human questions that I think we're going to need to grapple with. Please don't leave it to us, people like us. I think this is society as a whole. We all have to think through these questions together. So humans are very complicated.
Yeah. We could end on humans are complicated, but I'm gonna end on AI. Corey, and I think maybe we could do a quick one for all of you on this. But Corey, I'll start with you. Fill in the blank. The most extraordinary way AI will be used in 2050 will be.
Right. It's a very long-term prediction, but I hope that I think of all the applications. Like the healthcare and drug development, disease solutions, I think that's the most critical one. And hopefully by 2050, we would have really, really excellent systems that would make it. There will always be new diseases, there will always be new problems, but we can deal with them very efficiently, very fast, and we can solve a lot of the problems all across the world. That is applied really all across the world. That would be my, I think, like the most important thing of my mind.
And Jeff, how about you? What do you think the most extraordinary way AI will be used in 2050?
I mean, as Corey said, 2050 is a long way off. I think we have it. If we do things right, we will use AI to sort of improve nearly every aspect of human endeavor. And I think that's what we should aim for, is how do we make and take advantage of the capabilities of these systems in order to help us have better healthcare, have better education, make scientific discoveries more quickly to advance what we can do as people. And I think if we do that right, that's going to be extraordinary. And I'm super, super excited to see what happens.
Cool. James?
Well, I think, I agree with what my colleagues just said, but I also think, in addition, I hope that by 2050, AI would have helped us, at least the mirror that AI provides, would have helped us kind of be better humans ourselves.
Great. Well, thank you all so much. Really appreciate it. Give them a round of applause. Thank you, guys.